I am taking the next chapter, that is electrostatic potential and capacitance. Okay, this also have too many derivations, problems are there. One derivation and one problem, and one mass question and one two mass question is sure. Okay, so this is also a little bit difficult topic, just like electric field and so theories are a little bit complicated one. Okay, so but first of all, in order to understand what is electrostatic potential, let us we know that. Let us understand what is the gravitational potential energy. And a spring potential energy. Both we have studied in the first year. What is the gravitational potential energy? Okay. Suppose here is the Earth, gravitational potential energy of a body. Okay. Due to the gravitational force of the Earth. Here is the Earth. Try to understand this concept. So I will explain what is the potential energy concept. Then understanding electric potential will become simple. Okay. So let us try to understand what is the gravitational potential energy of a body. Let's try to understand. Okay. Due to the gravitational force of the Earth. So here is the Earth. Everywhere around the Earth there is a field. That field is called gravitational field of the Earth. Around the Earth, up to infinity actually, it extends up to infinity. The gravitational field of the Earth, it extends up to infinity. As it goes, as you move upwards, moving to the higher altitude, moves up and up and up, the gravitational force will become weaker and weaker and weaker, because it obeys the inverse square law of gravitational force of the Earth is on any body. The force always acts on another body. The force is exerted by one body on the another body. Force is not single in nature. Force does not occur singly. So means force does not generates by a single body. By the interaction of the two bodies only the force generates. The force does not occur singly. Okay, the gravitational force of the Earth on the body of mass m is, so of mass small m, here is a body kept mass m, kept in the field of gravitation, kept in the gravitational field of the Earth, then the force exerted on this body by the Earth, which was gravitational force. F is equals to G into mass of the Earth. M is mass of the Earth, m is the mass of the body, into m upon r square, where r is the square of the distance between the center of the Earth and the body. Okay. So upon r square. So as the means the gravitational force Fg, let us call it as, is inversely proportional to, upon means inversely proportional to the square of distance. As the distance increases, the distance between the body and the Earth increases, the gravitational force on the Earth decreases. So okay, because it is inversely proportional to the square of the distance. Almost all force laws are inversely proportional to the square of the distance. Okay, between the two bodies. The force occurs by the interaction of the two bodies. So always the force, almost all force laws are like that, only inversely proportional to the square of the distance between the bodies. Okay, so inverse square law is called as inverse square law. Okay, this gravitational force is attractive in nature, means the Earth drags the body towards it. So by the gravitational force, Earth drags the body towards the Earth by the gravitational force. Therefore it is attractive in nature. Now let us come into the means there is a gravitational field around the Earth. Okay. Now one body of mass is lifted from the surface of the Earth to a height h. A body of mass is lifted in any path. It is lifted, say in zigzag path or in a straight line path. If it is lifted, then at a height h, it is lifted to a height h of body m. So by how to lift the body? By an external force. I would like to lift this duster from the top of the table. I have to apply the external force on the body. So this external force is against the gravitational force. Why? So why gravitational, against the gravitational force? Gravitational force is always downwards, means towards the earth. I am applying the force on the body in the upward direction. Therefore, an external force is applied on the body of mass m to lift it from the surface of the earth to a height h. Now the body, any path, along any path is going to displace itself, lifted along this path it is displayed, or along the straight line path it is displayed, along this path it is displaced, means lifted. But the difference between the initial position and the final position of the body is h. Okay, what it is, the difference between the initial position and final position, this is the displacement. This difference between the initial position and final position is called displacement, is h now. Now work is done. Now when a body is displaced, work is done. Try to understand some basic concepts. ಏನೇನೋ ಬೇಸಿಕ್ ಕಾನ್ಸೆಪ್ಟ್ ಅನ್ನು ತಿಳ್ಕೊಳ್ಳೋದಲ್ಲ, ನೀವು ಕಲಿಸಿ ತಿಳಿಯೋದಿಲ್ಲ, ನಮ್ಗೆ ತಿಳಿಯೋದಿಲ್ಲ ಅಂತ ಹೇಳೋದು. ಒಂದು ಬೇಸಿಕ್ ಕಾನ್ಸೆಪ್ಟ್ ಆಫ್ ಸೈನ್ಸಿನ ಏನೇನೇನನ್ನು ತಲೆಗೆ ಹಾಕೊಳ್ಳಿಕ್ಕೆ ಟ್ರೈ ಮಾಡೋದ್ರಲ್ಲಿ ಇವೊಂದವು ಇಟ್ ಈಸ್ ಎಕ್ಸ್ಪ್ಲೇನ್ ಡ್ಯೂರಿಂಗ್ ದ ಥಿಯರಿ. ಅವೆಲ್ಲ ಬೇಸಿಕ್ ಕಾನ್ಸೆಪ್ಟನ್ನು ಎಕ್ಸ್ಪ್ಲೇನ್ ಮಾಡಿದ್ರು ಕೂಡ ಅದನ್ನು ಅರ್ಥ ಮಾಡ್ಕೊಳ್ಳೋದಲ್ಲ. ಆಲ್ಮೋಸ್ಟ್ ಸಿಲೆಬಸ್ ಮುಗಿಲಿಕ್ಕೆ ಬಂತು ಆ್ಯಕ್ಚುಲಿ. ಸೊ ಹೇಳಲಿಕ್ಕೆ ಬೇಜಾರು ಅನಿಸುತ್ತೆ. 90% ಆಫ್ ದ ಆಲ್ಮೋಸ್ಟ್ 80% ಆಫ್ ದ ಸಿಲೆಬಸ್ ಇಸ್ ಓವರ್. ಸೊ ಮಾಲೆ ಸರ್ ಎಲ್ಲ ರಿವಿಸನ್ ಮಾಡ್ತಾ ಇದ್ದಾರೆ, ಬಟ್ ಸರ್ ರಿವಿಸನ್ ಮಾಡಿದ್ರು. ಸೊ ಇವನ್ ಯಾರೋ ರಣೇಕರ್ ಸರ್ ರಿವಿಸನ್ ಮಾಡ್ತಾ ಇದ್ದಾರೆ. ನೆಕ್ಸ್ಟ್ ಕ್ಲಾಸಿಂದ ಅದನ್ನು ರಿವಿಸನ್ ಕಂಟಿನ್ಯೂ ಮಾಡ್ತಾರೆ ಅವರು ಆಫ್ಟರ್ ದ ಕಂಪ್ಲೀಷನ್ ಆಫ್ ದಿಸ್ ಟಾಪಿಕ್. ಒಂದು ಸರಿ ಆನ್ಲೈನಲ್ಲಿ ಆಯಿತು, ಎರಡನೇ ಸರಿ ರಿವಿಸನ್ನು ಮಾಡ್ತಾ ಇದ್ದಾರೆ. ಆಯಿತಾ, ಇನ್ನು ಕ್ಲಾಸ್ ಸ್ಟಾರ್ಟ್ ಆದಮೇಲೆ ಒಂದು ಬ್ರೀಫ್ಲಿ ರಿವಿಸನ್ ಮಾಡ್ತೇವೆ ಅಂತ ಹೇಳ್ತೇವೆ. ಇಷ್ಟಾದರೂ ಫೀಸ್ ಕಟ್ಟಲಿಕ್ಕೆ ಇರೋದಿಲ್ಲ. ಇಷ್ಟು ಏನನ್ನೂ ಒಂದು ನಯಾ ಪೈಸಾದಷ್ಟು ಫೀಸ್ ಕಟ್ಟಲಿಕ್ಕೆ ನಿಮ್ಮಲ್ಲಿ ಯಾವ ಮೊರಾಲಿಟಿ ಇದೆ? ಯಾವ ಒಂದು ಯಾರು ಫೀಸ್ ಕಟ್ಟಿದವರಿಗೆಲ್ಲ ಕಟ್ಟದೆ ಹೋದವರಿಗೆ. ಐ ಆಮ್ ಜಸ್ಟ್ ಅಬೌಟ್ ಟು ಆಸ್ಕ್ ದ ಸೆಕೆಂಡ್ ಇನ್ಸ್ಟಾಲ್ಮೆಂಟ್. ಈಗ ಯಾಕೆಂದರೆ ಆಲ್ಮೋಸ್ಟ್ 80% ಆಫ್ ದ ಸಿಲೆಬಸ್ ಮುಗಿಲಿಕ್ಕೆ ಬಂತು. ಸೆಕೆಂಡ್ ಇನ್ಸ್ಟಾಲ್ಮೆಂಟನ್ನು ನಾನು ಕೇಳೋದಿದ್ದೇನೆ. ಅಂತಂದ್ರೆ ನೀವು ಫಸ್ಟ್ ಇನ್ಸ್ಟಾಲ್ಮೆಂಟನ್ನೇ ಕಟ್ಟೋದಿಲ್ಲ ಅಂದರೆ ಏನು ಹೇಳಬೇಕು? ಸೊ ಜೂನ್ನಲ್ಲಿ ಕ್ಲಾಸ್ ಮಾಡಿದ್ವಿ, ಕ್ಲಾಸ್ ರೂಮ್ನಲ್ಲಿ ಫಸ್ಟ್ ಒಂದು 25 ಡೇಸ್ ಮಾಡಿದ್ವಿ, ಆಮೇಲೆ ಇಲ್ಲಿ ಜೂನ್ನಲ್ಲಿ ಮಾಡಿದ್ವಿ, ಆಮೇಲೆ ಇಲ್ಲಿ ಆನ್ಲೈನಲ್ಲಿ ಮಾಡ್ತಾ ಇದ್ದಾನೆ ಯೂಟ್ಯೂಬ್ನಲ್ಲಿ. ಆ್ಯಂಡ್ ಸೊ ರಿವಿಸನ್ ಮಾಡಿದ್ವಿ. ಇಷ್ಟಾದರೂ ನೀವು ಪಾಠ ಕಲಿಯೋದಿಲ್ಲ, ಯಾಕೆಂದರೆ ನೀವು ಬೇಸಿಕ್ ಫಿಸಿಕ್ಸ್ ಏನೋ ಅರ್ಥ ಮಾಡ್ಕೊಂಡು ಟ್ರೈ ಮಾಡೋದಿಲ್ಲ. ನಿಮಗೇನು ಬೇಕೋ ಒಂದಿಷ್ಟು ಎಕ್ಸಾಮಿಗೆ ಬರುವಂಥ ನೋಟ್ಸ್ ಕ್ಲಾಸ್ ರೂಮ್ನಲ್ಲಿ ಅದು ನೋಟ್ಸನ್ನು ಅರ್ಥ ಮಾಡ್ಕೊಳ್ಳೋದಿಲ್ಲ. ಕ್ಲಾಸ್ ರೂಮ್ನಲ್ಲಿ ಸುಮ್ಮನೆ ಟೈಮ್ ಪಾಸಿಗೆ ಕ್ಲಾಸ್ ರೂಮ್ನಲ್ಲಿ ಕೂತ್ಕೋತೀರಾ, ನೋಟ್ಸ್ ಬರ್ಕೋತೀರಾ ಅಷ್ಟೇ. ಅದರಲ್ಲಿ ಕ್ಲಾಸ್ ರೂಮ್ನಲ್ಲಿ ಬಂದು ನೀವೇನು ಅರ್ಥ ಮಾಡ್ಕೊಳ್ಳೋದು ಅಷ್ಟರಲ್ಲೇ ಇದೆ, ಚಾಟ್ ಮಾಡ್ತಾ ಕೊಡ್ತೀರಾ ಅಷ್ಟೇ. ನಮ್ಮ ಕ್ಲಾಸ್ ರೂಮ್ ಟೀಚಿಂಗ್ನಲ್ಲಿ ಅಡ್ಜಸ್ಟ್ ಆಗಿದ್ದೀರಾ ಅಂತೀರ. ನೀವು ಕ್ಲಾಸ್ ರೂಮ್ ಟೀಚಿಂಗ್ ಬಿಟ್ಟು ಎಲ್ಲಿ ಟೀಚಿಂಗ್ ಇದ್ದರೂ ನಿಮ್ಮಂಥ ಸ್ಟೂಡೆಂಟ್ಸ್ಗಳು ಅರ್ಥ ಮಾಡ್ಕೊಳ್ಳೋದಿಲ್ಲ, ನನಗೆ ಗೊತ್ತಿದೆ. ಆಯಿತಾ, ಅದು ವೇಸ್ಟೇ. ಕ್ಲಾಸ್ ರೂಮ್ ಮತ್ತು ವೇಸ್ಟೇ. ಮತ್ತೆ ನಿಮ್ಮಂತ ಅಲ್ಲಿ ಬಂದು ಚಾಟ್ ಮಾಡಲಿಕ್ಕಾಗುತ್ತೆ, ಟೈಮ್ ಪಾಸ್ ಮಾಡಲಿಕ್ಕಾಗುತ್ತೆ ಅಂತ ಅಷ್ಟೇ. ಓನ್ಲಿ ಡಿಮಾಂಡಿಂಗ್ ದಟ್ ಒನ್ ಓನ್ಲಿ ಅಲ್ವಾ, ಅದಕ್ಕಾಗಿ ಕ್ಲಾಸ್ ರೂಮ್ ಡಿಮಾಂಡ್ ಮಾಡ್ತಿದ್ರೆ ಒಂದು ಫೀಸ್ ಕಟ್ಟೋದಿಲ್ಲ. ಏನು ಹೇಳಬೇಕು ನಿಮಗೆ? ಇಟ್ ಈಸ್ ಲಿಫ್ಟೆಡ್ ಟು ಡಿಸ್ಪ್ಲೇಸ್ಮೆಂಟ್ ಈಸ್ ಎಚ್. ನಾವು if there is a displacement in the body, displacement is as it moves from one position to another position, then the displacement, for displacement work is external force is necessary to displace the body. External force on the body must act. Common sense. Just ಹಾಗೆ ಮೂವ್ ಆಗುತ್ತೆ, ನಾನು ಪುಷ್ ಮಾಡಿ ಮೂವ್ ಆಗುತ್ತೆ. My pushing itself is the external force. When there is a displacement, some amount of work is done. The work formula in the last case, W is equals to the force F into dr bar, where dr bar is the displacement, or dx bar, okay, small displacement in the dx bar. Even F bar dot, even S bar is the displacement, S is the displacement, then F bar dot S bar agutte. A small work is done, suppose small displacement, a small work agutte, then delta W is equals to small, even though small work is done, force is not small, force small agutte, force is, even though small displacement is there, it does run, now I have displaced to 10 meter, so while displacing 10 meter I have to apply some amount of force, even and if it is displaced by 1 millimeter, that same amount of force is necessary. Therefore F is delta F formula. Small displacement, small work done. Large displacement, then what it is, the work done is denoted by W. If small displacement is there, work done is delta W. In that case, a small work will be done. Delta is small. Okay. So F bar, force small agodilla, force small force again, body movement agodilla. So the same amount of force is necessary. Basic concept, common sense. Into delta dx bar. Okay, dx bar is the displacement. Okay, dr bar. Okay, dr bar is the small displacement, or even delta r bar. Okay, delta d represents a small change. Okay, dr bar and delta ಡಿಫರೆನ್ಷಿಯೇಷನ್ ಡಿ ಅಂತ ರೆಫರ್ ಆಗುತ್ತೆ. ಇಲ್ಲಿ ಇಂಟಿಗ್ರೇಷನ್ ಡಿಫರೆನ್ಷಿಯೇಷನ್ ಬಂತಂದ್ರೆ ಇಲ್ಲಿ ಡಿ ಅಂತ ಯೂಸ್ ಮಾಡಬೇಕು. ಇನ್ ಯೂಸ್ವಲ್ ಕೇಸ್ ಡೆಲ್ಟಾ ಅಂತ ಯೂಸ್ ಮಾಡಬೇಕು. A body displaced by a small displacement delta r bar, then the small work done is delta w is the scalar product of force in the displacement f bar dot delta r bar. Okay, so therefore now here the body is lifted to an height h along any path, say, and it is lifted to an height h, the work will be done. If the body is displaced, work will be done by the external force. I am lifting the body. That's why work is done by the external force. Okay, against the gravitational force, because the force applied is what it is against the external force of gravitation. Against the what it is, the work done by the external force is against the gravitational force. Gravitational force is dragging the body in the downward direction, but I am lifting it in the upward direction by the external force. Okay, I am applying the external force. Therefore, work done by the external force is given by the formula. The work done is equal to mgh. The formula last time notiddave. This mgh. So work done is equal to force. Force enagutte m into g. How much force I have applied? The question here is, if the body should not be accelerated. Acceleration antandre if the speed increases, then there is an acceleration. If the body is lifted with a constant speed, then there is no acceleration. Constant speed is there, means constant velocity, no acceleration. So in order to have the constant acceleration, the force applied must be exactly equal to the gravitational force. Downward force and upward force is is equal. The gravitational force is the downward. The external force applied by me to lift the body in the upward direction is external force, which both are equal and opposite same. The net force will be 0. Gravitational force is in the downward direction, Fg. The external force is in the upward direction, Fe. Then both are equal and opposite. The net force is what? Two forces are acting in equal and opposite. Then the net force is the difference between those two forces. Therefore, Fe minus Fg. Tug of war nodilva obru ee kade jigtare obru aa kade jigtare. The net force enagutte on the knot is the difference of those two forces. Yav force stronger irutte aa kade move agutte. Okay, so add agutte force or kade add agutte total force. No, difference of force will be counted. Who is applying more force, then automatically that side it moves. So Fe minus Fg, that should be equal to 0 agutte. Yake so Fe is equal to Fg. If Fe is external force is greater than what it is, the gravitational force, automatically the body accelerates. If net force is not equal to 0, then the body accelerates. If net force, if Fg is bigger, automatically the body ಮೇಲೆ ಹೋಗೋದಿಲ್ಲ. Gravitational force strong ಆಯಿತು, ಕೆಳಗಡೆ ಬಂದ್ಬಿಡುತ್ತೆ. Okay, but if no acceleration means external force applied should be equal to the gravitational force. In that case, the body will be moving upwards. ನೀವು ಕೇಳಬಹುದು, net force 0 ಆಯಿತು, the body ಹೇಗೆ ಮೂವ್ ಆಗುತ್ತೆ? So ಹಾಗೆ ತಗೋಬೇಕು. That the net force is 0 means external force is 80.000001 newtons more than the gravitational force. Then the body moves upwards with a constant speed, no acceleration, 0 acceleration. Move agutte constant speed ನಲ್ಲಿ, constant speed iದ್ರೆ acceleration is 0. Okay, so therefore external force applied is equal to the gravitational force. Then the net force on the body is 0. Then the body can be lifted with a constant speed, means no acceleration. Therefore, what is the external force applied? That external force applied is equal to the gravitational force. Gravitational force is a formula ಗೊತ್ತಿದೆ ನಮಗೆ. Gravitational force is m into g. One more formula for gravitational force. m into acceleration into gravity. Gravitational force is the formula ಗೊತ್ತಿದೆ. The gravitational force between the two bodies at the same time. The gravitational force is one more formula ಯಾವುದು? m into acceleration due to gravity at that place. Okay, so that is what it is, gravitational force. Okay, because G is nothing but it is G into me upon r square. Formula ಮಾಡಿದ್ದೇವೆ, the relation between small g and capital G. ಹಾಗಾಗಿ ಇದಿಷ್ಟು ಸೇರಿಬಿಟ್ಟು ಏನಾಗ್ಬಿಡುತ್ತೆ, G ಆಯಿತು. Therefore Fg is equals to what it is, m into small g. It is small g actually. Last year one derivation is gravitational topic, relation between what it is, gravitational G and gravitational constant, ಒಂದು ರಿಲೇಷನ್ ಇತ್ತು. ಸೊ ಓಕೆ, ಹಾಗಾಗ್ಬಿಟ್ಟು the force is equal to ಏನಾಗುತ್ತೆ, force is equal to m and the force is equal to mg. So displacement is h. Therefore work done is equal to force into displacement, force into h. Mg is the force, h is the displacement. Therefore work done is equal to force into displacement, force is mg, displacement is h. Therefore work done is mgh. Last year already explained. The work done, where it went? The work done is not lost. Work done is stored in the body. The body is stored in the form of an energy that is called potential energy, gravitational potential energy of the body. Work done lifting the body to an height h is equal to mgh. This work done is not lost. The work done is stored in the body in the form of an energy. That energy is called gravitational potential energy of the body. Why gravitational potential energy? The word gravitational potential energy because the work is done against the gravitational in the gravitational field of the earth, or work is done against the gravitational force of the earth. That's why it's called gravitational potential energy of the body. The gravitational potential energy of the body symbol is U is equal to mgh. Okay. Now work done is equal to gravitational potential energy. Okay, work done is equal to gravitational potential energy provided the force acting on the body should be a conservative in nature. What is the conservative force? Coming to the conservative force, gravitational force, spring force, etc. are conservative. Conservative force is that force if the work done against that force is path independent. In any path, if it is lifted in this path, or lifted in this path, or lifted along this path, work done will be same mgh only. Therefore, the work done is W is equal to mgh, is path independent. Work done against the gravitational force is path independent. In any path you displace the body, the total work done will be mgh only. Therefore, if work done against a force is path independent, in any path the body displaced, the work done will be same, then the force is called conservative force. Okay, therefore the gravitational force is conservative because work done is lifting the body to an height h is same if it is lifted along any path. Only the initial position and final position displacement h is important here. That's why such forces are called what? Conservative forces. If the work done by an external force against the conservative force is what it is, conservative in nature. If the work done by an external force against a force where the force is conservative in nature, it will be stored in the body in the form of potential energy. ಯಾವ ಫೋರ್ಸಿನ ವಿರುದ್ಧ ವರ್ಕ್ ಮಾಡಿರೋದು ಗ್ರಾವಿಟೇಷನಲ್ ಪೊಟೆನ್ಷಿಯಲ್ ಎನರ್ಜಿ ಆಗಿ ಸ್ಟೋರ್ ಆಗುತ್ತೆ. Against which force the work is done by an external force will be stored in the body in the form of potential energy. So, you know, bill and jagtiya. So, arrow is dragged in a bow. Then you have displaced the arrow. Okay, you have to shoot the arrow with the force. You are applying the external force and you are what it is dragging the arrow in your direction. You have applied the what it is external force. So, in this case, the arrow is displaced means what it is, the work is done. The work is done will be stored in the arrow in the form of potential energy. Therefore, when it is released, it will move with high speed. Why? When high speed it is moving, means it is having kinetic energy. This potential energy converts to kinetic energy. Whenever the body is under motion, there will be a kinetic energy. Okay? Where this kinetic energy the arrow got? From the stored potential energy. So here, it is conservative in nature because you are dragging the arrow against the tension of the string. Tension is a conservative force. Okay. So anyhow, the work done by an external force on a body against the what it is conservative force will be stored in the body in the form of potential energy. The gravitational force is a conservative force. What is the conservative force? If work done against the force is path independent. In any path the body displaces, the work done will be same, and that forces are called conservative force. The work done lifting the body to a height h along any path is path independent. The work is done against the gravitational force. Therefore, the gravitational force is conservative in nature. The work done by an external force against the conservative force, it will be stored in the body in the form of potential energy. It is the theory. ಯಾವುದೇ ಒಂದು ವರ್ಕ್ ಡನ್ ಮಾಡಿದೆ ಒಂದು ಬಾಡಿ ಮೇಲೆ ಬೈ ಎನ್ ಎಕ್ಸ್ಟರ್ನಲ್ ಫೋರ್ಸ್ ಆ ಎಕ್ಸ್ಟರ್ನಲ್ ಫೋರ್ಸನ್ನು ನೀನು ಯಾವುದ್ರ ವಿರುದ್ಧ ಅಪ್ಲೈ ಮಾಡಿದೆಯಾ, ಎ ಕನ್ಸರ್ವೇಟಿವ್ ಫೋರ್ಸಿನ ವಿರುದ್ಧ ಅಪ್ಲೈ ಮಾಡಿದೆಯಾ, ಆಗ ಆಟೋಮೆಟಿಕ್ಲಿ ವರ್ಕ್ ಡನ್ ಲಾಸ್ ಆಗೋದಿಲ್ಲ. ವರ್ಕ್ ಡನ್ ಬಿ ಸ್ಟೋರ್ಡ್ ಇನ್ ದ ಬಾಡಿ ಇನ್ ದ ಫಾರ್ಮ್ ಆಫ್ ಪೊಟೆನ್ಷಿಯಲ್ ಎನರ್ಜಿ. ದಟ್ ಈಸ್ ದ potential energy just explained here comes the electrostatic potential energy. Potential energy the work done will be stored in the body in the form of potential energy. In this case, the work done is against the gravitational force or in the gravitational field of the earth. Therefore, that potential energy is called gravitational potential energy. Work done, W is equal to work done is equal to potential energy. What is the potential energy? Work done formula mg. Therefore, the potential energy of the body in displacing to a height h, lifting to a height h against the gravitational force is mgh. Okay, this when the body is released, now it falls downwards because now this potential energy converts to kinetic energy. That's why the body, what it is, gets a velocity. Potential energy, kinetic energy formula is the kinetic energy formula. Kinetic energy is equal to mv square. As it is released, the body is released. The gravitational force of the earth is dragging downwards. Automatically, it is moving downwards with a speed of velocity of v. Then automatically, it gets the kinetic. The body is in motion. It gets the kinetic energy. Body motion is kinetic energy. Okay. The energy possessed by the body due to the motion is called kinetic energy. Formula is mv square. In this case, the potential energy converts to kinetic energy. Therefore, but at any position, total energy is constant. Total energy means potential energy plus gravitational energy is same. At the maximum height, the potential energy, total energy is same. But here, at the maximum height, if it is at rest, total energy is in potential, no kinetic energy. If it is released, it is halfway set. In this case, it is under motion, therefore it has some kinetic energy, and it is having some height from the earth, therefore it is having potential energy also. Therefore, in this case, it is total energy is potential energy plus kinetic energy. Total energy is always conserved. If in the conservative field, the body is under motion, then the total energy is always constant. At the maximum height, the total energy, in between also same potential energy. When it is about to reach the ground, then also potential and total energy is same. About to reach the ground, in that case, potential energy is almost zero because height is zero, means potential energy mgh is zero, means potential energy is zero. But it will move with high speed as it approaches the ground. Its velocity keeps on increasing. At the about to reach the height, its velocity is maximum. In that case, total energy will be in terms of kinetic. At the maximum height, total energy is potential. In between, the total energy is partially potential and partially kinetic. Therefore, in a conservative field, total energy of a body is conserved, but total energy will be in terms of potential and kinetic. Then the gravitational potential energy of the body equals to mgh when it is lifted to a height h. So that is our conservative force. Try to understand what is the conservative force. A conservative force is one where work done by an external force, work done by a body, by an external force apply the work displacement of body, work done by a body, by an external force against, where external force is applied against the conservative force. Against the conservative force is path independent. Then if the work done by an external force against let us define gravitational force. Let us what it is. I am arguing that gravitational force is a conservative force. Why? The work done by an external force against the gravitational force is path independent. Such path independent work done are called, the path independent work done by an external force against some existed force is called what? Conservative force. The gravitational force is what? Conservative force, because the work done against the gravitational force is path independent. Work done against the gravitational force is path independent, therefore gravitational force is conservative. ಯಾವ ಪಾತ್ನಲ್ಲಿ ಲಿಫ್ಟ್ ಮಾಡಿದ್ರು ಕೂಡ again the body is lifted by an external force. This is external force is applied against the gravitational force is downwards, the external force is upward. Then this work done in lifting the body to an height h is path independent. ಯಾವ ಪಾತ್ನಲ್ಲಿ ಲಿಫ್ಟ್ ಮಾಡಿದ್ರು work ಸೇಮ್ ಆಗುತ್ತೆ. Then therefore the gravitational force is conservative. Now coming to the then the work done will be stored against the work done against the what it is conservative force will be stored in the body. Work done on the body where the work is done against the conservative force is stored in the body in the form of potential energy. If the work is done against the what it is gravitational force, where gravitational force is a conservative force, will be stored in the body in the form of what? Gravitational potential energy. Spring force is also conservative force in nature. If a body spring is dragged to a displacement of x, then the work is done by the spring. The work is done is stored in the spring in the form of potential energy. That's called as spring potential energy. And the spring force is conservative in nature because work done against the spring, the stretching against the spring force. I am stretching the spring against the spring force. Spring is having its own tension. Tension means force. So I have to work. I have to apply the external force to stretch the spring against the tension of the string. So path independent. You stretch it in any direction, the work done will be simply depends upon initial position and final position. Therefore, the work done against the spring force is path independent. Therefore, the spring force is what? Conservative in nature. And the work done will be stored in the spring in the form of potential energy, that is called as spring potential energy. Now coming to the electric potential energy. Coming to the electric potential energy, if a charge q is placed in the space around the charge, there will be a field called gravitational field. Okay, sorry, they called electrostatic field. Electrostatic field, by static, the charge is at rest. Okay, the charge, source charge q is at rest. The electric field is denoted by E bar. E bar is the formula of E bar at a point P. The electric potential, so the electric field at the point P is given by 1 upon 4 pi epsilon naught. It is q divided by, but it is r square into r cap. The electric field at the point P, E bar is equals to 1 upon 4 pi epsilon naught q upon r square into r cap, where r cap is a unit vector directed from, suppose that it is the charge is placed at O to P. The electric potential at the point P, B bar is that one. Okay, so there is an electric field around the charge. If a test charge q is displaced from the point R to point Q, in any path if it is displaced, say, along the straight line path, from the point R to point Q, a charge is displaced along the straight line path. If it is displaced from R to point Q, along the straight line path, or along the what? Zigzag path, the work done. So suppose it is a positive charge. The test charge Q is also positive. And there is an electrostatic repulsion between plus Q and this Q and this Q. Now I have repulsion means this is also positive charge. The test charge Q is also positive. The force is what? Electrostatic force will be the repulsive nature is this charge will repulse this charge. Therefore, this charge is moving outwards. When it is set free, this charge is what it is. Allowed to move freely when it is moving outwards. Therefore, this because plus repulse, but by an external force, I am moving it from the point R to the point Q along any path. Then work will be done. Work will be done against the electrostatic force or against the electrostatic field. In the electrostatic field, against the electrostatic force or in the electric field of the source charge Q. The charge is displaced. This work done will be stored in the charge. Will be stored in the charge in the form of an energy. That energy is called as